Today I got a crash course in capacitors. Not by choice though. My heat pump went out, so there's no heat in the house, and I've pretty much narrowed the problem down to a faulty capacitor for the compressor motor in the heat pump. Now, whether you have an air conditioner or any other type of electric motor that has a capacitor, the testing procedure is the same. Here are the capacitors that are involved with the compressor motor on my air conditioner. There's 3 of them. This one and this big honker here are called the run capacitors. They are for keeping the motor turning once it's started. And this one is the start capacitor. This one packs a little bit more juice than these two. Now, I'm not really familiar with a capacitor and the technicalities of how they work, but what I do know is that with just an old-fashioned analog ohm meter, you can test a capacitor to tell if it's good or bad. So, I'll start with this big brick here. The way you test these is you set the ohm meter to ohms, which means that if you touch the 2 terminals together, the needle should swing from the left to the right. So I'll do that for demonstration. Yeah, it's working. It looks like it's adjusted pretty sensitive, so I'll turn it up there. So we'll touch these together and boom. Okay, so you know what an ohm meter is and how it works. To test a capacitor, you apply the terminals to each terminal on the capacitor, and what should happen is the needle should go up slightly and then sweep back down to 0 as the capacitor soaks up the small amount of energy that is applied to the terminals from the tester. But anyway, we have our ohm meter set up here, and before working with a capacitor, it's important to make sure it's discharged. I've heard that these can knock you back on your butt if they have a full charge and you touch the terminals. So the way to discharge a capacitor is to take a metal device, in this case my wife's favorite nail file, and make sure it's insulated on one end and touch both terminals like this. If you short the terminals to one another, it discharges the capacitor. So next, now that the capacitor is discharged, I'll apply the terminal here, and now watch this needle as I apply the second one. It should sweep over here and then crawl back as it soaks up some current. Just like that, see? So it sucks it back down. Now it has a small amount of energy stored in it now from this tester. See, if I touch it again, it goes a little more. But see, it doesn't do it. With each successive application, it doesn't hold as much energy. If I short it again and give up that little bit of energy that is in there, that needle should jump right back to the middle of the screen here again. Just like that. So this capacitor, I think, is good. I don't think this is a way to test these extremely accurately. You would need a digital voltmeter with a capacitance setting, but this is a good way to tell basically if it's complete junk or not. So, capacitor 1, not complete junk. So I'll set this in the good pile over here to your right. This little guy is the other run capacitor for my motor, and we'll apply the same steps. We'll make sure it's discharged. And as I touch this terminal here, 3, 2, 1, boom. This is a little capacitor, so it doesn't make the needle jump as much. So see, now it has a little bit of a charge, so it's not jumping anymore. But if I go like this and short it out, go again, 3, 2, 1, just like that, I have good reason to believe that this capacitor is also serviceable. Now for the third one, this is the motor start capacitor. It looks a little bit different, but it functions the same as those other two. This one should cause the needle to jump quite a bit, because this is a pretty powerful little guy. So I'll touch the terminals here. 3, 2, 1. Wait a minute. If you've been paying attention up to this point, you know that that isn't good. You see that needle all the way over to the right and just staying there? In my non-professional opinion, I think that this capacitor is bad. And I'll tell you a secret. I already knew that, and I have a replacement. I drove into town today because I really want the heater to work, and I bought this guy, which is a direct replacement. So let's see how the new one behaves. Get my terminal set up here. And 3, 2, 1. See that? That's a good capacitor. And if I touch it again, see it soaks up the energy, and every time I touch it again, it doesn't make the needle swing as far to the right. One more time here, I'll short it out. And 3, 2, 1. So I really think that this capacitor is the reason that my compressor motor wasn't starting on my heat pump. So for only $16, I think I'll be able to fix my heat pump. It should have been $13 because I called the appliance parts store on the phone and they quoted me a price of $13. But magically, when I got there, the price had jumped to $16, which I think is shady business practice, but I digress. It's still a bargain if it will fix my air conditioner. So hopefully this little tidbit of knowledge that I've shared with you can help you in your electric motor troubleshooting adventures. Thanks for watching.